gives us 6 neutrons. And then the first energy level will have 2 electrons, and the second energy level will have 4. That gives us our 6 electrons. Okay, so we know that the carbon atom is not stable because it needs 4 more electrons. So what that means is that carbon can share, because carbon is going to become stable. It's going to fill up its valence electron shell by sharing electrons rather than by transferring or accepting electrons, okay, or donating or receiving electrons. Carbon is going to share electrons. So let's just do one that's common, carbon dioxide, okay. Oxygen has 8 as its atomic number and 16 as its mass number. So in the nucleus of an oxygen atom, you have 8 protons, and then 16 minus 8 is 8 neutrons. The first energy level has 2 electrons, and the second one has 8. Nope, it doesn't. The second one has how many? Because it's got a total up to 8. So the second energy level has 6, right?
Put it in the fridge.
So oxygen would be stable if it were to gain or share 2 electrons with another molecule. So this is how that would look.
Yeah, and then I got another, there should be 2 bags.
In the center, and carbon has, I'm going to draw the valence electrons as dots. Carbon has 1, 2, 3, 4 valence electrons, 4 electrons in its outer energy level. And then we've got oxygen over here that has 2 valence electrons. Well, that oxygen is going to be stable if it shares 2 electrons with carbon.
Were you supposed to peel the paper off of it, or?
Okay, so once they share a pair of electrons, those electrons belong to both the oxygen and the carbon. Now here's another oxygen with 2 valence electrons, and it can share these last 2 electrons with carbon. So what we end up with is a structure that has 2 double covalent bonds in it. You can think of these lines as representing, there's always 1 electron on each end of the line. So each line represents 2 electrons. All right, so let's look at it. Is carbon stable now? Has carbon gained 4 electrons like we said carbon needed to do? Carbon needs to gain 4 electrons. Well, here's 1, 2, 3, 4, the 4 valence electrons. 1, 2, 3, 4. And then here's 5, 6, 7, 8. So the 4 that it shares with oxygen would satisfy and complete its valence shell or its outer energy level of electrons. And the oxygen will also gain 2 electrons each. So now oxygen has an additional 2 electrons that it shares with carbon. That gives it 8 electrons in its valence shell. And this one over here also has an additional 2 electrons that it shares with carbon. So each oxygen is going to be satisfied and carbon is going to be satisfied. They're all going to be stable. And the chemical formula for this molecule, since it has 1 carbon atom and 2 oxygens, will be CO2, and we call that carbon dioxide. So what we are looking at now is a covalent bond. Covalent bonds are the strongest chemical bonds. Ionic bonds are a little bit less strong. So covalent bonds are the strongest. Ionic bonds are next. And then we're going to talk now about hydrogen bonds. But before we do that, we need to look at molecules that have polar and nonpolar covalent bonds. Now what you just saw, carbon dioxide, is called a nonpolar covalent molecule. And that is because even though the oxygen atom has a slightly stronger pull on the electrons than the carbon does, which makes it slightly negative. You don't have two ends of the atom with opposite charges. So the electrons are shared equally between the atoms, and that means that the molecule is nonpolar, because both ends of this molecule are slightly negative due to the oxygen being slightly negative. That little delta sign, it just means slightly negative. So it's nonpolar if you don't have a slightly negative end of the atom and a slightly positive end of the atom. So let's look at something that is polar. All right, water. The water molecule is a polar covalent molecule, and it's formed by taking the oxygen that has two valence electrons, hydrogen, which has one valence electron each, and hydrogen is going to be satisfied with two. Oxygen is going to be satisfied by gaining two. So what we end up with is a water molecule where each hydrogen atom shares two electrons with oxygen. That gives oxygen the two extra valence electrons that it needs to be stable. And what happens here is that the hydrogen atoms are sort of bent away from the oxygen. The oxygen has a slightly negative charge because it is more electronegative. That means it has a stronger pull on the electrons that are being shared than the hydrogen ions do. So the oxygen is more electronegative, so hydrogen is going to take on a slightly positive charge. That gives you one end of the molecule that is negative and another end that is positive. That is called a polar covalent molecule because it has different charges at different ends of the molecule. So water is an example of a polar covalent molecule. Okay, then we were also going to talk about hydrogen bonding. So hydrogen bonding, let me think of a good example of a hydrogen bond. Well, two water molecules can be attracted to each other. So if you have one water molecule here, and you know this is the slightly positive end, this is the slightly negative end, another water molecule is going to be attracted to it. The second water molecule will be attracted to its oxygen end, will be attracted to the hydrogen end of the first water molecule, because the negative ends will be attracted to the positive ends. So you wouldn't have, the second molecule would not line up with the hydrogens facing the hydrogens. And this bond that forms between those two molecules is called a hydrogen bond. Hydrogen bond is not a bond that forms between atoms. The ionic and covalent bonds form between atoms to form compounds or molecules. The hydrogen bond forms between molecules. Okay, so hydrogen bond is the weakest of the chemical bonds, and it forms between two different molecules instead of atoms, instead of forming between two different atoms. Okay, so water itself, the water molecule itself, has two polar covalent bonds that hold the oxygen to the hydrogen. But then another water molecule that is attracted, weakly attracted to this water molecule, and let's draw a different orientation. Let's draw the other water molecule up here. Okay, so another water molecule being attracted to this water molecule with its hydrogen end facing the oxygen end of the first molecule, that is a hydrogen bond that forms. And that is a bond that holds molecules together weakly. Hydrogen bonds are used to form shapes in molecules, to give them a special shape. They help give DNA that double helix shape, and they'll give proteins their special shapes. but they are weak chemical bonds. So the chemical bonds, the covalent are the strongest, and then comes ionic, and then comes hydrogen. And now we need to talk about how molecules form by combining or by breaking apart. So we're going to talk about dehydration synthesis, which is a type of chemical reaction where you take two smaller molecules. Let's see, trying to think of how an easy way to do this. So if we take two molecules of glucose, glucose is shaped like a hexagon. So that's the shape of a glucose molecule, and one of the molecules is going to have a hydrogen attached to it. And then the other one is going to have an OH attached to it. And what does hydrogen and OH form? That's two hydrogens and one oxygen. So if you remove that hydrogen and you remove the OH, you can form water. So that's what happens. What happens is the hydrogen and the OH, or the hydroxide groups, are removed. The two glucose molecules combine and form what's called a disaccharide. They combine, and then the water is given off as a byproduct. So this is dehydration synthesis. This is what happens when molecules form, when large molecules form from smaller molecules. And hydrolysis is the opposite of that. That is when two smaller molecules form from a larger molecule. So let's say that we have our disaccharide called maltose, which is it's a sugar, but it's a disaccharide. So when water is added to that disaccharide, water is used to split it apart, and one of the hydrogens attaches to one of the sugar molecules or one of the glucose molecules, and then the OH attaches to the other glucose molecule. So that's where your water goes. So this is called a hydrolysis reaction.